Yeah, welcome. Welcome, everybody.
To post-lunch.
To post-lunch. This is learning from video games. This is the session you can go to after all the really complicated enterprise AI things that your employer sent you to. We're going to talk about video games. This is us. I'm Paris. This is Mars. This is Tim. We took advantage of being in San Francisco last week and went to our second ever baseball game, which also happened to be something called Star Trek Night. Who knew?
That's why we went.
That is why we went, but we also enjoyed the baseball game.
The tickets were cheaper than a baseball hat with a chevron on it.
We mostly wanted the hat, and then we ended up staying for the baseball game because it was fun.
It's a weird sport.
But Paris, Mars, Tim. You can tweet us during the presentation. Our handles are on the corner of the screen, if you can see behind me. So we're game developers, academics. Tim and I both have PhDs in computer science. We're not sure why they would do that, but somebody gave them to us. We're researchers, teachers, annoyances. We've written a lot of books for O'Reilly and some other publishers that publish yellow books with for dummies on the cover, but we don't talk about them. We mostly talk about video games and mobile, and increasingly lately, AI. So that's what we're here for. We're really excited to be here. This has been a great conference so far. We are most well known for being involved in the video game Night in the Woods, which won a British Academy Award, a BAFTA, and an IGF Award in the recent months, surprisingly. We didn't make Night in the Woods, we just work on it, but we're very proud of that game. So we are professional game developers most of the time. We're from Australia. Australia is this place. We have strange accents because we're from Australia.
Sorry.
We're sorry. Specifically, we're from Tasmania, which is the tiny island down the bottom. It's a little bit bigger than West Virginia, but has the population of Wyoming.
Thank you, Wikipedia.
Thank you, Wikipedia. Hopefully that contextualizes it for some of you. Tasmania has a city called Hobart that looks like this. This is where we're from.
It's paradise.
Visit. It's paradise, yes.
Never come here. It's terrible.
So we're here to talk about a couple of things. We're going to talk about a little bit of history and a little bit of things that you can do with AI today, and then we're going to talk about how AI is used in video games, which is two specific ways, and then we're going to talk about what you, presumably non-game developers, can take from that. We like this picture of a dog. We have a couple of warnings before we dive in. The first warning is that there's some stuff in here that might bother some of you if you're not big into video games. There's some high motion video game stuff. There's some slightly violent video game stuff. There's some cartoony monsters. There's some blood and guts. It's nothing you won't be familiar with if you've played a recent video game, but just in case it makes anyone feel uncomfortable, we thought we'd put that up there because we don't want anyone to feel unwelcome. So occasionally we'll have some motion that's from video games. Please feel free to look away or leave. It's fairly tame, but still.
And jump scare.
Jump scares. Our second warning is this is a UX talk. So we're in the UX track of this conference. If you're more interested in the machine uprising, I'm sure there's a talk on either side of this room that you could go to that's more about algorithms and other things like that. This is a UX talk in the UX track. Hopefully this is a nice respite from all the really crunchy talks you've been in, talking about vendors and customer-centric solutions and things like that. Hopefully you'll enjoy the relaxing afternoon with us. We also speak reasonably fast, mostly by design, but also because we can't really help it. So hopefully that's okay. But please feel free to come and talk to us afterwards if you need help figuring out what we're talking about. Why are we at an AI conference? Well, more than 50% of published AI work is actually game-related at the moment. Games are huge. Games have had user-facing AI longer than pretty much any other field. And that's user-facing AI, so things that the user interacts with are related to AI. This comes from a much longer history than most people realize.
All right, so let's just talk a little bit about history because you can't really get anywhere without a start. So in the beginning, actually pretty much the first games or the first sort of games created were also generally some of the first computers created as well. Because it was seen very early on that, this gimmicky game that people could play, you could convince people to buy your fancy vacuum tubes using that. And in this stage, we're pretty much like is it even technically possible to make a computer game? Can you make this? And the answer is yes. So two really early systems were both, this is the Nimitron. Two of them were the Nimitron and the Nimrod. They were both in the 40s to the 50s. They were very early computers, is maybe a little bit kind, but they did compute. And you could play the game of Nim. If you don't know what the game of Nim is, it's basically just you take marbles until one person's forced to take the last one, they lose. It's a solved game, pretty much. It was taken around to fairs and exhibitions going, look at this fantastic new computer we have invented. It had, interestingly enough, intentionally bad moves programmed in, because even in the 40s, computers were powerful enough to kick the pants off computers, at least in games like this. We then get to Birdie the Brain, which played noughts and tic-tac-toe. It's called tic-tac-toe here, isn't it? Noughts and crosses in Australia. It was very hard. This is a solved game, as I hope you can all realize that this is a solved game. But they didn't actually play it perfectly because, again, it was too hard. So they had difficulty levels, and like the hardest one was perfect play, and then there were levels in
Pretty sure
between.
this guy has Birdie on the show floor.
Somewhere. Again, exhibition machines. Then we sort of get into commercial games AI. Computers got a lot more powerful, a lot cheaper. You could do a lot more. Arcade starts springing up. Narrative games start becoming possible. We start getting characters. Most games are still kind of based on, I guess, what you call solvable games, even if they're not a traditional game like NIM. So one game I really want to talk about is called Hunt the Wampus, which it may be the first text adventure, choose your own adventure game that wasn't in a book. And it may be the first game to have a villain, which is the Wampus, and it would hunt you based on your actions. You'd move around and go like, you hear the Wampus over here, and like, it's actually pretty cool for what it was. To call this AI might be a little bit hard. It is literally just a bunch of if statements. But again, it was sort of getting started. Then I want to talk about this game called The Amazing Dr. Nim, which was actually a mechanical AI, which I love. I love mechanical computers a lot. The reason it's really interesting is because it was actually perfect play. This thing could always beat you, guaranteed. And it had a manual. It was sold as a tool to try and convince children to get interested in computing and AI research. So they made a computer game to beat people to try and get them interested in it. Then we got into the era of, can AI beat humans? Is this even possible in games that aren't as simple as like tic-tac-toe? And by around, it's kind of obligatory to put in Deep Blue or Deep Fritz. By that time, we have chess computers that are capable of not only beating the world champions. Chess computers now are so good it's not actually fair to put a human up against them. They get wiped. And then quite recently, we had AlphaGo, which is an amazing project. I really love it. But by this point, we kind of sort of moved away from just beating humans. That is not so much a game's objective anymore because we've done it. We have beaten humans. It's time to now look what AI can do.
Wrong way. So we get to today, and the approaches that we take today are a little bit different because we know that AI can beat humans. Given enough time and enough developers, you can write a system that will mathematically solve and fundamentally beat almost any human player, even if it's not the cleverest way or the most fun way. So it's no longer about making a system that's clever. It's about making a system that's entertaining and, most of all, makes a believable experience. You are creating and manipulating experiences. People no longer have the patience for these tedious and often unbeatable experiences of the past. So we're not trying to make a colossal opponent. Quite often, we're not even trying to make something simulating a human opponent at all. In fact, we're trying to get all these little pieces. And what we call intelligence in games now is a couple of fundamental things in almost all cases. It's good old-fashioned AI, a term that almost predates most of these things. They called it GoFi, G-O-F-A-I, where it's just you decide what you want to do, and you go over there, and you do it. You do something there, you come back, you repeat. It's all these steps, pick an order, repeat. So we have things like pathfinding, which is deciding where to go. They're mostly A-star based still. We haven't bested that. And we have goal fulfillment, which is telling it the thing that it wants to do, that it's going to try its mightiest. So we have things like finite state machines, which is just telling you from different states what states you can get to. We have behavior trees, which are a different structure for a similar thing. We have utility AIs, which are just a table of the same thing. We have something called GOAP, which is goal-orientated action planning, which is a way to work out what possible actions you can do at any given point. And almost more recently, unexpectedly, the Monte Carlo tree search, which is combining a tree of possible options from every point and random selection. Together, you randomly select from the options that have worked for you before, most often. And you might be thinking, but where are the neural nets? This is what we've been talking about all week. And they've only been used a little, most oftenly to control single units in large SWAT games for each one's fight or flight response, or when they should attack certain players. So this is Supreme Commander 2, and we also have Total War examples of this. But mostly we found that was really hard to debug. And we realized that the game AI that you write should be in service to the player experience above all else.
So, because AI is really in video games for UX, AI in video games is not really about intelligence. It's actually about making a good experience. So hopefully, when we said user-facing AI at the beginning, that kind of clued you into where we're going with this. The modern approach that video games are taking with AI is to make people feel challenged or feel a certain thing, not actually challenge them that much. You've got to make the player feel powerful. You've got to make the player feel afraid. You've got to make the player feel loved or like they're having a conversation with something. Hunted, scared. There's all sorts of emotions. 8kindsofFun.com is a great place to learn about the different ways games make people feel. Turns out fun means a million different things. It doesn't just mean fun. It could mean scared, so on. But how do you make the player feel? Well, there's really one great way to make the player feel things with AI in video games, and that's to lie. With some niche exceptions, AI in games is focused on making a better experience, and it kind of just lies to do it. AI is now too good. It's too powerful, so we kind of make it stupider and tune it more to make the player feel something or take the user experience in a certain direction. We have some examples, and here this is where some of the stuff from video games comes in, so if you're uncomfortable with pseudo-horror imagery from games, now would be the time to look away. This is BioShock. It's a 2007 video game. It's a very stylish, avant-garde, postmodern experience in a really weird, interesting-looking environment. In BioShock, it's a shooter game. The AI enemy always misses their first shot. Always. And this obviously immediately makes the player feel very powerful and like they've got pretty good control of the situation, or that they're just damn lucky. It's tricky. Uncharted, which is a very popular run-and-jump platforming game, similar to BioShock. The AI can't actually shoot you until it's nearly missed you too many times. So again, you start off feeling very powerful. The AI is trying to kill you, but it won't actually start doing that until it's missed you a bit. Again, trickery, lies. People feel like there's something going on, and they kind of fill in the gaps themselves a lot of the time when it comes to these game AIs. So if you give them kind of a hint of something going on, they will take the bait and run with it, and you don't have to tell them anything else. They'll believe.
Our brains like to make up a story if we're told that there's one there.
Yeah, we're very good at that. Half-Life. Does anyone remember Half-Life these days? Okay. Hey. Half-Life's like a really important FPS game from the late 90s, 1997, 1998. It had these troops that tried to flank you. Flanking is really hard to implement in AI, especially in 1997, 1998 video games. So in Half-Life 1, the NPCs would just shout flanking and then move to a random location. It's entirely faked.
All the comments are going, oh my god, that's so clever.
It made people feel like the AI was being super intelligent. It wasn't. It was just running around randomly while shouting something that it could kind of be doing. Fear in 2005 did a similar thing. In Fear, the AI would regularly shout out, I need reinforcements. And then, because Fear is a really intense, pretty hardcore game, there's a lot of enemies everywhere, so the player would continue moving through the level and find more enemies and feel like the enemy they just met called reinforcements. What was actually happening was no more were being added. It was just, that's the level design. It created an illusion of a giant organized system, GOAP, GOAP.
Fear got a lot of positive feedback for how intelligent the squads would communicate, and they weren't. They just happened to be next to each other.
It's a really good trickery. It felt like there's this giant coordinated system. It wasn't actually there. Abe's Odyssey is another game that has, that is very loud. Abe's Odyssey is another game from the mid-90s that was a platform game. It took a similar approach. Each AI had its own set of rules. So when one AI shouted, look out, if there was another in its path, it would duck. They didn't actually talk to each other. They just had like call and response actions that would respond to each other. It looked like they were facilitating some great big network of communication. They were really just having very simple responses to each other. It's all fakery and lies. Lots of little pieces can create a very giant system. A thing that feels like a very giant system that's not actually a giant system. Humans love to build giant, impressive things. That's why I'm standing in front of these ridiculous screens. And trying to make it feel like it's large and impressive. This is a trap. We're much better at making lots of tiny things and letting them work together, especially when we're trying to create a user experience for video games. Our brains tell us and then stuff happens.
So we keep kind of going like, you know, why is it important? And that's because gamers are entitled jerks. Okay, that's a bit mean. Not all of them, but there are lots of gamers who are entitled jerks.
Anyone here a gamer? Yeah, okay. You're all jerks.
You're all jerks. Well, no, not all of you, but enough of you. Enough of you. So the gaming community can be quite hostile towards their developers, which is quite sad. So I'm not going to make you read this whole thing. This is a comment on a video from Oblivion. Does anyone here remember Oblivion? It's a few people. It's a very large world role-playing game where it actually had kind of advanced AI for its time. It's a bit clunky and weird looking now. And they had this video talking about their new, what they called Radiant AI system, which was very intelligent and could create its own problem-solving solutions. And I love this comment here. I'm not going to make you read the whole thing or anything. I'll just show you the important bit, which is they're faking AI with parlor tricks, because people didn't believe that people could write an AI like this, so they're 100% convinced it was scripted. So because they gave the players a good experience, the people complained about it. So, I mean, they had to be faking it, ergo, they lied. And that makes it bad, so we should boycott the game and never buy it. This all leads into this problem of if you create something that's too big, you end up with emergence.
So emergent behavior is a term that we give to when you give a system a goal. And a lot of these intelligent systems are built off the idea that you can give it a thing to do, and it will figure out how to do it. And this is a common sci-fi trope that you might remember, where like you told the robots to keep mankind safe, and they figured out the most efficient way to do that was to kill them all, or something. And we get a lot of similar things in video games. There are lots of examples where like we told the NPCs to defend themselves, and we thought they'd shoot people, but instead they realized that rocks were more efficient, or something. And sometimes that's good, and your players are going, wow, this is realistic. They're defending themselves like a person would with anything they've got. But sometimes it leads to weird behavior where they've figured out that they could stand on their head, and that makes them less likely to be headshot or something. And then you get these behaviors that not only, if they're bad, you can't really figure out what's doing it, but also if it's good and you change something and they stop doing it, you can't replicate it, which means you're beholden to this code that you can't change, or you can't change the way that you want to because you've made this clever system that is doing its own thing. But emergent AI is not your friend. Emergent behavior is not desirable because your AI should work for you.
So if you're at the talk from Danny Lange yesterday, who's the head of AI for Unity, arguably the biggest game engine in the world, depending on how you count, he regularly reminded the audience that the art when you're using AI, especially video games, comes from knowing when to tune the AI or turn the AI off or stunt the AI or tweak the behavior, gently nudge it in a certain direction. That's kind of what we're getting here. You need to gently nudge things to make a better user experience when you're building AI in video games, and we really think that's something the rest of the world could learn.
So now we'll talk a little bit about some sort of specific things games have started doing quite a lot of to make things a little more obvious. The first one I want to talk about is mechanical expression, which is a really important moment in games. And it sort of ties back into that people like to be told a story. So no one likes magic numbers. This is true both in games and any system. No one realistically likes a black box. It's confusing, it's weird. So what you need to do is you need to have some way of having the AI expressing its mechanics. So here's a quick video of Dishonored 2. Has anyone here played Dishonored 2 out of curiosity? A few people. It's a very large game with a lot of different systems, and a big component of it is being stealthy. So we're playing terribly here. We're just walking right up. We're making too much noise. You can actually see he's got like a how alert-ometer popping off his head. It's not very diegetic, but it is very useful for the player. And that helps explain what's happening. You no longer feel ripped off when the AI turns around going, aha, I see you, because you're being told how much he's seeing you. We're literally telling you what the AI is doing. We could show this as a number if you wanted to, but a little chart with a lightning bolt thing off his head's kind of cool. The same game also had these completely terrifying, like, bird sword monster. They're the most scary things in any video game ever. So they were programmed guards, and this is the thing I love. They're actually speaking debug messages as they're going around the game. We're not going to play the audio because it's way too loud. But they're actually saying what they're doing. They're literally telling you what they're doing. And because they have like sensors everywhere, they were too hard to sneak up on. So they sort of discovered during playtest, people need to be told what it's doing. So it's going, hey, I'm now scouting. Wait, I heard a sound. I need to track to where that sound is and go for it. And I'm willing to bet, I don't know this, but I'd be willing to bet during the making of this, Arcane was probably using these for their own testing and then just decided to leave them in and then record them properly, because it does make debugging them a lot easier, I imagine.
They're recorded with the voice actor of who's canonically their creator. So it sounds like their creators debug messages, which is especially clever.
And then sort of, there's a lot of ways of doing narrative in AI. So far we've been talking about it's kind of constrained into individual moments. What about when you want to do the big picture? Well, there is a whole bunch of different sort of ways. We're going to talk a little bit about sort of 3 of them. So really early on, there was a program called Tailspin. I think it was the 70s, wasn't it, Paris?
It was the 70s, yeah.
Very, very early on. It's actually not too bad for what it is. That would actually generate sort of fables was the idea. It would generate these little like stories behind me there. It was just given a list of rules and then told to sort of solve it based on a start state. So it's sort of like a Markov chain crossed with a Pathfinder, basically.
This is not very clever, but for the 70s, it was kind of interesting.
Then in 93, we have things like Minstrel coming along, which was designed to generate sort of epic tales, so sort of like Arthurian sword and sorcery sort of stories. It's a little bit better, but for 93, this isn't too bad, really. And this is, again, it's still sort of like a problem solver. It's not a neural net or anything fancy. This is just a straightforward sort of pathfinding problem in its core. Then we get to I've never figured out how you pronounce this. Sepopokol? Who knows how you pronounce it? And this was a whole planning algorithm, and that's a quote from the paper there. And what you could do is you basically set up the state saying, here's what I need the game to, here's how I need the story to be, here's how the start state is, I want you to solve the problem and then generate a story of you doing so. And it actually works surprisingly well, and this has been used in a few games. One of them was called Facade. Which was quite recent, where it would actually have like conversations where it was dynamically generating story for you to talk to on the fly. But that's not the only form of narrative. This is sort of very text-heavy narrative. There's other forms of narrative out there. So the thing is, why do we care? Well, we care because people want to feel. This is all about feeling again. So things like Tailspin got the job, Minstrel's better. But sometimes taking a less efficient route is better, which is why what I want to talk about now is Left 4 Dead. So has anyone played Left 4 Dead or Left 4 Dead 2? Quite a few people, actually. Cool. I'm impressed with the number of people playing games. Sometimes when I go to conference, I'll be like, has anyone played giant game that everyone should have played? It's like one person. Like, oh,
the audience just stares at us with their arms crossed shaking. We don't do fun.
Which is curious as to why they came to the talk.
Yeah.
I want to hear about this video game thing.
But Left 4 Dead had this thing called the narrative director. So it didn't do any text narrative, but it did do, I believe they called it tension narrative, where it was an AI that would watch what the players are currently doing, where they're physically located, and would try and ramp the tension up or down based on what was currently happening. So it would spawn new zombies behind them or in front of them. It would change the music on the fly to make it like, whoa, there's something behind me music. And it actually worked pretty well. So it sort of was like all feeding into this system, which would then feed it back out to try and make the game, well, scarier, really, more tense.
Literally have no chill.
Hopefully this is visible. It's a little bit hard to see, unfortunately. So has anyone here played Alien Isolation?
Oh.
Right, okay, so if you want a proper scary game, play that. So it's basically like a Ridley Scott-style Alien, well, not basically, it is a Ridley Scott-style Alien game. And what you've got is you've got one of these alien xenomorph things hunting you, tracking you through the ship. This is a player, actually, he's hiding in a locker, like, terrified for their life. The alien literally tears the door off and kills them. It's one of the scariest games you'll ever play, and how it works is really fascinating. And it sort of relates very much similar to what Denny Lange said about building systems out of multiple AI. It actually has what the developers called two brains. So the first brain is a normal sort of pathfinding brain. It knows exactly where the alien is, and it knows exactly where the player is. It has perfect knowledge. And what it does is it just goes, okay, so I know where the human is, they're over there. Then it tells the second brain, you might want to head in that direction. And what this did is it created this sort of really much more terrifying feeling than if it was too good or if it was just too stupid. You had this sort of alien that if it got too close to you or heard you or smelt you or, can they see? They don't have eyes. Detected you in some way, it would kill you. But its ability to track you directly was intentionally stunted by this other brain going, no, just over there. Check out this room. Just, have a quick look. And one of the really cool things about Alien Isolation is that it's about a 10 to 15 hour game, depending how quick you play. The alien creature, the actual physical object that goes stalking around, wow, that looks much better. It's a really scary game. It actually only teleports twice. So throughout the actual game, it is tracking you, the player, the whole time. It's not just jumping too near where it is. It's got this other brain going, no, let's go to level 3. Let's go have a look in the armory. That sort of thing.
It runs around the ship for real. The only reason it teleports is for cutscenes.
Yeah, so it doesn't actually cheat at all. It's just scary because it's intentionally made stupid, but that makes it scarier than if it was too good. So next thing I want to talk about briefly is what I guess you could call helping development. I haven't quite worked out what the right term is for this, if anyone knows a better term. But let's just jump straight into an example. So this is Ghost Recon Wildlands. Has anyone played this? This is a very recent game, so be surprised. It's very pretty. So this is modeled it's an open world game. It's played on a 30 by 30 kilometer map, so I guess that's 22 by 22 miles, something like that. Sorry, I don't know miles. This is a French game, so it's also in KM. It's got multiple biomes. It's way too big to be handcrafted. There's no way a human, even a team the size of Ubisoft, would not be able to fill this in any meaningful time. So they actually had an AI go in after they did the height map. The AI goes in and fills in details. It was building not only like forests and snow-capped mountains and that sort of stuff, but it was actually going all the way in and setting up roads and pathing for cars to drive through. And it was actually building whole towns with little people inside them who had their own lives that they would go through. And then they just had a human come in at the end and make tweaks where necessary for specific missions. So if there wasn't a mission in that town, they just let the AI take it. So realistically, I'd say the AI is one of the level designers. So it did both micro and macro sort of assistance in building up the level design. There was another quite recent game, much smaller, called The Witness. It came out last year, was it, Mars, I think?
Yep. It's available on iOS, so if you're going home on a flight, buy it before you go. It's really fun.
It's a really fun puzzle game, a very, very beautiful, stylistic sort of visuals. It's a puzzle game, so you have to wander around a lot. So these are some rocks. These are impenetrable rocks. You can't walk through these rocks. The developers of it made what they called a walking monster. I'm really sad they didn't actually make a physical monster, but it was an AI system that would move through the map invisibly in the same way a human did. And what they're able to see is their impenetrable rocks were actually penetrable. So the red areas are things that you couldn't get into, but the white areas are things that could traverse. So it's a little bit hard to see, but what this means is technically, depending on how the player walked, they could skip over the invisible barrier that they weren't meant to walk into the rocks, move around the rocks, but then because of the design, they couldn't then walk back out. So you could actually have your players trapped inside rocks, and you would never want that. They would be so mad. Like, they got mad about Oblivion having good AI. They're going to get really mad if they get trapped in a rock. If you went to Danny Lange's talk, you've probably actually seen this video or a similar one. So this is a short GIF of I say GIF, not GIF. It's a short GIF of a corgi being animated by a neural net, the goal is to try and train it so it can move at 75 miles an hour. I don't know if he ever achieved this goal. This is by a developer called Punches Bears on Twitter. I don't actually know their real name. They're called Punches Bears in my head.
I think he works at Unity.
Oh, okay, well, there you go. And he was live streaming his sort of cute corgis, and his idea in this case was he was trying to make it so that certain behaviors, such as animation of creatures, doesn't have to be handmade. You can have an AI kind of take care of it. I personally think this might not scale. Like, it's great for a cute corgi. If you did this for a human, the developers are going to complain because your human's like some sort of jelly monster. Games have actually failed before due to bad animation. One game quite recently, Mass Effect Andromeda, actually got a terrible review just because one character didn't talk quite right. So, great for corgis, probably wouldn't use it for humans. But there's this great potential we're only just starting to untap, really, with this sort of stuff of speeding up game development using AI. Now, the other great thing, and we're not going to talk too much about this because that's basically what Danny's talk was about yesterday. Go see that if you're interested. Well, you can't go see that. It was yesterday. Go watch the recording of that. Go to Unity's website. I'm sure they'll have stuff up there. But something that's great about video games is they're one of the best places for simulating the real world. They're close enough to the real world for a lot of different things. And this is something that the video game engine manufacturers are really pushing heavily now. And this sort of all started quite a few years ago. So this is a brief video of training AI bots using Doom. I assume, has anyone here played Doom? I hope to see a lot of hands. Yeah, Doom's good. So this is like old school Doom. This was just trained with pixels, so it's just fed pixels and then it's told forward, back, left, right click, effectively. And the great thing is it learnt really, really well. And this is, I think, the first time this happened. And there's this great quote from one of the developers where they actually said, it opened a new field for research in that the competition proved that deep reinforcement learning works in 3D environments, which significantly increases its real-life practicality. And this is Doom. This is not, the most realistic of worlds, but modern game engines are actually terrifyingly realistically close. And it's something that I think we're going to start seeing more and more and more of, if only because Unity and Unreal are pushing a lot of that. But it is a great environment for just testing out your AI theories. Which sort of leads us on to our lessons.
So, obviously, you can see that games are fascinating. You should play games. It's interesting to look at the history of games, the history of AI in games, and stuff like that. But most of you are probably not game developers. You're probably doing something much more important.
Out of curiosity, is anyone here a game developer? Hey!
Oh.
Yes.
Awesome.
Awesome.
This is great.
Tell us what games you play after.
Yeah.
Or make. Or both.
Exactly. No, but realistically, most of you are doing much more important things than game developers. We're the game developers. We don't do anything important. And you're wondering why you should care about what game developers think about AI. Because obviously this isn't really particularly crunchy AI compared to a lot of the stuff that you've seen at this conference. This is kind of like, it calls itself AI, but really it's just kicking the tires of AI. Why care? Well, games are very complicated but constrained simulations. As Tim said, Doom was incredibly useful for furthering the field of deep learning, reinforcement learning through looking at a visual scene and then manipulating it. That's a really old game. Modern games are a much more vivid and rich simulation of the real world in a constrained problem space that you can actually work with. It's tremendously valuable to look at these things and think about what you can do and how you can experiment. But again, not all of you are looking at user-facing problems with AI that can be have something like that be beneficial for them. And in that context, games are worthy of thinking about as well, because they're one of the most rich HCI, human-computer interaction experiences you can have. Compared to pretty much any other way people interact with a computer, the amount of information exchanged per minute with a computer when somebody's playing as a game is very high compared to almost anything else they might interact with. And you can learn a lot because it's effectively just type accelerated compared to any other task that's not a game. So by thinking about it in that context, you can get some learning from how a game treats things. Games are also really popular. Billions of people are playing games. When Danny Lange in his Unity talk yesterday mentioned how many billions of hours were played in a Unity game each month, like I heard several people in the audience visibly go, and like, yeah, games are just, there's huge amount of gameplay happening every moment, and there's so much data being collected that everyone really should be thinking about it in the corner of their brain, because people interacting with computers, it's all related to what we do. Every facet of AI is encompassed in a game. There's all of them. Games have been working with AI since the very beginning, and it really pays to think about how you might take advantage of that, either through applying something from games or using the learnings of a game in your work. So we're just going to summarize now.
Thank you. So what we've talked about is mostly that people often associate game AI as something that plays a game, whether it's because of the association between AI and robots or autonomous action. They think about it as a replacement for a person that just plays a game against you or for you. But it also, very importantly, is helping to generate and model things in games and for games, and this is becoming more prevalent by the day. If anything, it might overtake the AI that's being made to play games. And game developers, as an industry almost, have decided this is all about delivering an experience more than making a cleverer system, because that's not necessarily better. It's better to have a lot of smaller things that you can control than making this, what I was told is a term that Americans might not understand, magnum opus, your perfect example, your one brilliant thing that you've ever made that you deliver to your boss, and it's so clever, but it doesn't make it better for its purpose. So we hope you learned something, and thank you very much for listening to us. We have lots and lots of games that you should play and that we will thank. We also have a lot of sci-fi and pop culture references that we put in here. We have some sources that are very good.
If anyone hasn't watched Person of Interest, the TV show, it is the best exploration of AI in a medium that's like television, movie, video game in a long, long time. So if you're interested in AI, you should watch Person of Interest.
It's like Minority Report.
But
someone makes this great AI that predicts crime, which people are actually doing now. I've been reading all about that recently.
Creepy.
And we're the humans.
Yeah.
So we have a book signing at 3:15 today in the O'Reilly booth, which is in like an hour. It's not about AI, it's about Swift, but you can come and talk to us about AI and get a free book. I think we have like 6 minutes for questions if anyone has any questions.
6 minutes and 20 seconds.
Otherwise, you can tweet us and get in touch any other way.
So did anyone have any questions? I think there's mics somewhere. What?
So what's your magnum?
So the question is, what's our magnum opus? Well, we don't have one, because we've got thousands of little tiny things that we've all then put around. We make a giant octopus out of that.
I can answer on their behalf, and they could probably answer on mine.
Oh, okay.
The dialogue engine that they made, that was their major contribution to Night in the Woods, was then released as open source. They make a lot of open source tools, especially open source games tools, and that has helped a lot of people who weren't traditionally game developers make things that are narrative games that explore things and express themselves, and they've had lots and lots of people writing letters to them and contacting them on Twitter saying, hey, you made this framework and this environment that I can now write narrative games in, and now I make games.
That's
and a lot of
pretty
people
much right.
being very thankful.
Her magnum opus is that she helped create Westeros Craft, which is the world's largest hand-created digital environment, as far as we know.
It's
like
an
80
entire
nerds building
recreation
Game of Thrones in Minecraft.
Yeah, it's actually really cool if you like Game of Thrones or Minecraft.
I should have put that in the slides. It looks great.
It does look great. Yes, sorry?
Yeah, I got a question. So do you guys think that as more AI gets advanced, that games will be less fun?
No. So the question was, do we think that as AI gets more advanced, games will become less fun? No, because so I mean, with a few exceptions, we've pretty much abandoned the idea of just making hard AI. So there's things like OpenAI project, which is trying to make an AI for playing Dota, which is actually a fairly complex game. It currently can't beat the world champions, but they're the world champions, and they've only been working on it for a couple of years. Like, give them a little bit more time, it'll be beating the world champions. It would already trounce everyone in this room.
It turns out really hard games are only interesting to a very specific small audience. And like, there's still those sort of games being made. So if anyone's played like Super Hexagon, that's that sort of game that's ridiculously hard and is designed to be ridiculously hard. And the fun is it's really hard. But there's a lot of different kinds of fun. So I mentioned a website earlier, 8, so digit 8, kindsoffun.com is a great place to learn about the different ways a game can be fun. And I think as AI gets better, games will have more different kinds of fun rather than just challenge.
I think it's applicable to general user experience. It talks about being like suitably challenged and feeling fulfilled and feeling scared and appreciated and things like that. That there are all these different definitions for it.
Sorry, there's a person at the back. Yeah. Yeah. The question was, we've done dialogue, but like chatbots. So we ourselves have not worked on any chatbot stuff, at least not to the best of my knowledge.
So we write dialogue engines that are designed to be used for games that have a narrative. So if anyone's ever played something like Mass Effect, where there's characters you can talk to, and you pick a response and it moves to another one, we work on dialogue engines for that sort of game. And one of the things we're trying to solve is making it so people who are not programmers can write the dialogue in an environment that lets them support and debug that dialogue. So maybe they could run a debugger through the dialogue and solve it to see where it stops and where it starts, and where they can like put breakpoints in the dialogue and make sure that every piece of the dialogue is executed. So like the game state can be solved. So we're kind of applying learnings from compiler technology to narrative video games. Hope that makes sense.
As for conversation design, I would highly suggest you take a look at Facade. It did come out a few years ago. It's a really interesting look at that sort of thing.
It has got adult content. It's
right, yes,
about,
sorry,
like,
yeah.
relationships and stuff like that.
Very adult content. Sorry, you. Sorry.
Yeah, so there's a genre of game called ImSim, which is basically designed to be mostly based on emergent behavior, and it doesn't scale that far. You have to stop at some point and start curating the behavior.
If you went to Danny Lange's talk yesterday, he actually had a specific section about learning from players, where they had a racing car game, and it's actually been used more than just in Unity. It's been used, Microsoft used it in one of their Forza racing games, where they had a good human player play it, and then teach the AI off it. Yeah, it definitely generates new behavior, but it's sort of domain constrained, I would definitely say, in that like it works great for like a racing game. For a game a bit more like Dishonored with like those terrifying clockwork creatures, it probably wouldn't work that well. They'd probably become too good too quickly or become boring.
If anyone's familiar with motion capture for like cinema and video games, it's kind of similar to that in that you can capture a large proportion of something's movement. You can generate a large proportion of something, but then you need a human to step in and clean it up a bit and make it a bit more effective. It's kind of the same deal.
Do you have a...
No, it's okay.
Oh, no?
Do you have any thoughts on, like, in the way that the internet sort of created whole new genres of games, will really good AI create openings for new types of games?
Yep.
Yeah.
So the question was, will the increase in AI and as AI just gets better in general, will we get new sort of types of games being generated? Yep. I'm 100% certain of that. I don't know what they'll be. But I mean, just 5 years ago, cow clickers weren't a thing, and now cow clickers are a thing. Walking simulators are less than 6 years old, and now they're one of the biggest genres in games out there. Yes, I don't know what they'll be. I imagine we're probably going to start getting some... we may actually start getting games where it's you versus an AI specifically, like an AI who's been highly trained, and it's going to be like 5 humans versus 1 AI, and it's trying to take on all of you at once sort of thing. I honestly have no idea what they'll be. But there will very much be new games coming out which are focused on some of these new AI capabilities that we're more or less getting.
The timer says 25 seconds, so that was probably have to be the last question. But if anyone has any questions, we're here for the rest of the day, and we'll be at the book signing in the expo. Please come and see us. Please message us. Thank you for coming to our talk.